Hey guys, this is AAF and in this video we are going to be discussing multiples. In the previous video we had a discussion about factors, and in the video before that we talked about the different types of numbers. Together these three videos sum up the course for chapter number 1, numbers. So in case you have missed out in the previous videos, I suggest that you do go and check them out. Moving on, let's discuss the concept of the least common multiple. So if we have two numbers, say 48 and 21, each of the numbers are going to have their own multiples. 48, for example, has the multiple 96, 21 has the multiples 42, 63, 84, 105, and so on. At the same time, these numbers are also going to have some common multiples, and not just one, they're going to have an infinite number of common multiples, numbers that are multiples of both 48 and 21. So unlike common factors, we cannot enlist all the common multiples of two numbers. However, we can find out a few examples, and we can also find out the least common multiple, which is obviously going to be a single value. So now I'm going to be walking you down the path to finding out the least common multiple of a group of numbers. Now this group could consist of 2, 3 or even more numbers. First thing you need to do is to use prime factorization and express each number as a product of its prime factors. If you're not familiar with how this is done, check out my video on factors. I have provided the link in the description. So once we have expressed these numbers as a product of their prime factors, we're now going to take one number and write all of its prime factors, because the least common multiple is going to be a multiple of both of these numbers. So it's going to be a multiple of, in this case, say 48. So it's obviously going to contain all the prime factors of 48, so I can enlist them just in one go. We're not going to be concerned with 48 anymore, and we're now going to move on to our second number, which is 21, and can be expressed as 3 multiplied by 7. Now since this least common multiple is also going to be a multiple of 21, therefore it must also contain all the prime factors of 21. So it must contain 3 and 7. Now the list of prime factors that I wrote down, which are basically the prime factors of 48, already consists of 3. So I'm not going to write 3 again, but since it doesn't include 7, I am now going to multiply this number that I have written right here by 7. So the answer I'm getting, that is the least common multiple, will be 336. So 336 is the least number that is a common multiple of both 48 and 21. Let's have a look at another example. So if we have three numbers, say 36, 48 and 26. First of all, we're going to express each of these numbers as a product of their prime factors. And once we have done this, we're going to pick one number. In this case, let's say I pick 36, and we're going to write down all of its prime factors straight away. Now we're going to go over the remaining numbers. So the remaining number includes 48. So now I need to write down the prime factors of 48 over here that have not already been written. So 2 has been written twice here, but 2 appears 4 times in the prime factorization of 48. Therefore I'm going to write 2 more times. And since 3 appears only once and I've already written a 3 here, I'm not going to be writing a 3 again. So I'm just going to be multiplying this number by 2 twice. Next, we're going to move on the third remaining number. So this number is a product of 2 and 13. 2 has already been written over here 4 times, and therefore I need not to write it. And I'm just going to be writing 13, which has not been written over here even once. So I'm going to multiply this number by 13, and the answer that I'm going to get is going to be the least common multiple. These two are basically the same number, just expressed in different forms, so we can consider either number. So let's talk about this prime factor form. It contains all the prime factors of 36. It contains 2 twice and 3 twice. It contains all the prime factors of 48. It includes 2 4 times and 3 once. And it also includes all the prime factors of 26, which are 2 and 13. So since this number is including all the prime factors of each of these three numbers, this number is going to be a common multiple of all of these numbers. And since we did not write any prime factor unnecessarily. This number that we have is the least common multiple. If we want to find out the other common multiples, we just need to multiply this number with different numbers, say 2, 3, 4, and those are all going to be common multiples. But there cannot be a common multiple which is smaller. So now let's have a look at a few questions. The question says, John, Peter, and Paul were each given a piece of string equal in length. John cut his string into equal lengths of 2 meters, Peter cut his string into equal lengths of 3 meters, and Paul cut his string into equal lengths of 5 meters. If there was no remainder in each case, find the shortest possible length of string given to each of them. Since this string can be divided into a number of strings of lengths 2 meters, 3 meters, and 5 meters. So in other words, we can say that the length of the string is going to be a common multiple of 2, 3, and 5. And since 2, 3, and 5 are all prime numbers themselves, we need not to get into the prime factorizations, and we can just say that the shortest possible length of string will be the product of all of these three numbers, which is equal to 30. Moving on, the next question says, buses following route A leave the bus station every 5 minutes. Buses following route B leave the bus station every 6 minutes. Buses following route C leave the bus station every 9 minutes. 3 buses following the routes A, B, and C leave together at 1300 hours. What is the next time when buses following all 3 routes leave the bus station together? So the time it takes for the buses to leave together the next time is going to be a multiple of 5, 6, and 9. Therefore, we can say that this time is going to be the common multiple of 5, 6, and 9. So now that it is clear that the time that it takes the buses to leave together is going to be the common multiple of all of these numbers, we need to see if it is the least common multiple. And since the question says what is the next time, we know that it is the least common multiple that we're going to be talking about. And so from here, the question is pretty straightforward. So we're going to express 6 and 9 as a product of their prime factors, which tells us that 6 is equal to 2 multiplied by 3, whereas 9 is equal to 3 multiplied by 3. 5 is a prime number itself, and therefore it cannot be expressed as a product of its prime factors. So in order to find out the least common multiple, first we're going to write down 5, which we know is the first prime factor of this least common multiple. Second, we're going to see which of the prime factors of 6 have not already been mentioned, and if they have not been mentioned here, we're going to write them. So both 2 and 3 have not been written yet, so we're going to write 5 multiplied by 2 multiplied by 3. And now we're going to see which of the prime factors of 9 have not been written yet. So 3 has been mentioned once, and only one 3 is remaining which has not been mentioned. So we're going to add a 3 to the LCM, which gives us 90, because 5 multiplied by 2 multiplied by 3 multiplied by 3 is equal to 90. However, beware that this is not the answer to the question, because read the last sentence once again. It says, what is the next time when buses following all 3 routes leave the bus station together? So the question does not ask the time it takes for the buses to come together, but it asks what is the next time when the buses are going to be together. So the answer that we have is that every 90 minutes these buses are going to leave the station together. So if the last time they left the station together was at 1300 hours, the next time they're going to leave the station together would be 90 minutes after that. And since 90 is equal to an hour and a half, we can say that it's going to be an hour and a half later than 1300, which is equal to 1430, or in other words, 2:30 p.m. Moving on, let's have a look at another question. The question says, the lowest number that is a multiple of both 60 and n is 180. Find the smallest possible value of n. So this is a peculiar question, because in this question we have not been asked to find out the least common multiple. Instead, we have already been provided with the least common multiple, and we have to find out one of the numbers in the group. So first we're going to find out the prime factors of 60 and 180, which gives us 60 is equal to 2 squared multiplied by 3 multiplied by 5, whereas 180 is equal to 2 squared multiplied by 3 squared multiplied by 5. Alright, So if I recall the way that we find out the least common multiples, we first write down all the prime factors of one number and then add the prime factors from the second number which have already not been written. So if we say that we've already written down all the prime factors of 60, that would be 2 multiplied by 2 multiplied by 3 multiplied by 5. We need to add another 3 to it to make it the least common multiple. This means that this 3 is coming from the second number, and so n must contain at least one 3. However, it is going to contain two 3's. There are two 3's over here and only one 3 in 60. Therefore, the two 3's must be coming from n. The rest of these numbers are common to both 60 and 180, and therefore these numbers may and may not be present in n. However, since we have to tell the smallest possible value of n, we are only going to be considering the absolutely necessary prime factors, which are 3 and 3. So n is going to be equal to 3 multiplied by 3, which is equal to 9. I hope that you found this video helpful. Please don't forget to like, subscribe, and comment. Thank you.